This is review for your trigonometry quiz, okay? Alright, so we will take a look at the first one. Okay, so just remember, you guys, that you do need to remember your formulas, right? So just remember, right, your guys' SOHCAHTOA, right? Which helps you guys to remember that sine is opposite over adjacent. Cosine is adjacent over hypotenuse. And lastly, that tangent of theta is opposite over adjacent, right? So when you guys have number one, all it's asking is to find tangent. So in the perspective of this angle, we do know that 20 is the opposite and 15 is the adjacent. Now just remember, you guys, right? Opposite is the furthest side from the angle, and adjacent is the side length right next to said angle. So just pretend like, right, 20 is your quote-unquote up, so that side length, that angle wants to be the furthest thing away from your quote-unquote up, right? So 20 is the furthest side, and adjacent, you guys, is your buddy. The adjacent side is just going to be right next to your angle, right? And you guys just consistently remember that across from the 90 is the hypotenuse. But in this case, they only give us opposite over adjacent for tangent. So that means tangent is opposite over adjacent. Now, remember, you have to simplify this if you can. So you're going to divide top and bottom by 5. So that's going to be 4 over 3. So that answer is 4 over 3. Okay, tangent of theta, yeah? Remember, here's the angle, tangent is opposite, and the adjacent. So this one's gonna be 3 over 4, right? Can't simplify that, so that's all you could do. Okay, cosine. Cosine, okay, so here's our angle, yeah? Cosine is adjacent over hypotenuse. Sorry, adjacent over hypotenuse. So here's the adjacent side, and here is the hypotenuse. So adjacent over hypotenuse. Now, this is something you guys can simplify. 2 over 16, you guys can divide top and bottom by 2. So that's rad 15 all over 8. And that's as simplified as you guys can get with that one. For number 4, here's this angle perspective. So remember, sine is opposite over hypotenuse, right? So our answer is going to be 10 over 5 rad 13. Now, there's a few things we can simplify with this fraction. Number 1, we can simplify 10 over 5. So if you guys divide top and bottom by 5, you guys get 2 over rad 13. You could put a 1 in the front of the radical if you want, but you don't have to. Okay, now you can't have a radical in the denominator. So to get rid of that, you need to multiply top and bottom by rad 13. So we get 2 rad 13, you guys. Rad 13 times rad 13, all that gets you is just 13. No more radical, no more square root symbol. And that is going to be your answer for that one. Okay, now let's get to 5 and number 6, 7, and 8. Okay, so when you guys do this, when you are finding a side length, you're going to set up a some type of proportion, right? You're going to set up some type of equation using the trig. So let me just kind of bring this over here, right? Let me bring the SOHCAHTOA down with us. Okay, so there's a reference. All right, so since we're trying to find a side length, so here's our angle perspective, yeah? There's our angle perspective. So from that angle perspective, this is the opposite, this is the adjacent. There's only one trig function that uses opposite and adjacent, and it is tangent. So tangent of the angle equals the opposite over the adjacent. You guys put this over 1, and then you guys cross multiply. X times tan 57 is just x tan 57, and 13.4, you guys, times 1 is 13.4. Isolate your x, so you're going to divide both sides by tan 57, right? Cancels. So this is what you guys gotta put in your decimals. Now, when you guys round this to the nearest tenth, now let me bring up the decimals real quick, okay? Split view, Okay, now here's decimals. Now, when you plug this into decimals, please, please, please make sure you hit this wrench tool and it is highlighting degrees, right? It has to highlight degrees. So you guys go to here, 13.4 divided by functions, tan 57. And if you guys round that to the nearest tenth, look at the 7. The number next to 7 is 0, so you don't round it up. So that's simply just going to be 8.7, right? That's simply just going to be 8.7. Okay. All right, good stuff, good stuff, good stuff. Okay, number 6, right? We have this angle. Okay, we have the adjacent side. 14 is adjacent to that angle, and x is the hypotenuse. So this is going to be cosine. So cosine of 23 equals to 14 over x. Put that over 1, and you guys cross multiply. X cosine 23, you guys, equals to 14, and you guys divide both sides by cosine 23. Cosine 23 cancels, and this is what you guys gotta plug into your decimals. So you guys get your decimals out. We go here. We got 14 divided by functions cosine 23. And if you guys round that to the nearest tenth, right, it's going to be 15.2. 15.2, right? 15.2. Okay, so for number 7, you guys, right? Okay, so for number 7, okay, we got this angle perspective, yeah? X is the adjacent side to that angle, 6 is the hypotenuse. So adjacent hypotenuse, this is definitely going to utilize cosine. So cosine of the angle equals to adjacent over hypotenuse. So that's going to be 6, right? Put this over 1, you guys cross multiply. So x times 1, you guys, is x. 6 times cosine 66 is just 6 cosine 66, right? Now, x is already isolated in this case. So now all you guys gotta do is just plug in that into your decimals. And as you guys can see, I already plugged it in. 6 cosine 66 in your decimals, you guys, round it to the nearest tenth. That is just simply 2.4, right? 2.4. Okay, number 8. Now, from this angle perspective, yeah, 14 is the opposite, x is your adjacent, right? So the trig function that utilizes opposite and adjacent, you guys, that is your guys' tangent, right? That's your guys' tangent. So tangent of 26 equals to opposite over adjacent, right? You guys put this over 1 and you cross multiply. X tan 26 equals to 14 times 1, which is 14. And then you guys divide both sides by tan 26. So you can isolate that x. Tan 26 is cancel. So we need to plug in 14 tan 26 in the decimals. And if you guys look at the decimal screen, I did put 14 tan 26. And if you round that to the nearest tenth, that is 28.7, right? 28.7. Okay, now we have here. Now, this one, you guys are trying to find an angle. When you're trying to solve for an angle, this is where you gotta use sine inverse, cosine inverse, and tan inverse to isolate your guys' angle, which we're gonna use as theta. So, same deal. Here's that angle. 10 is the opposite, 8 is the adjacent, and the only trig function that uses opposite and adjacent is tangent. Tangent of theta equals to opposite over adjacent. Now, we want to solve for this angle. So to get isolated, to get rid of the tan word, you guys, this is where you have to do tan inverse. Because if you tan inverse, the tan inverse and the tan cancel, so all that's left, you guys, is tangent theta equals tan inverse of 10 over 8. And if I go to my Desmos, you guys, right, go to functions, right there was tan inverse and then 10 divided by 8. Round that to the nearest tenth, you guys get 51.3 degrees, right? 51.3 degrees. Okay, number 10, right? From this angle perspective, this is the opposite and hypotenuse, so you guys have to utilize sine. Sine theta equals to 8 over 11. You guys sine inverse to both sides, right? And theta basically is just sine inverse of 8 over 11, right? And once we plug this into your Desmos, and I don't think I did it here, so let's see. Functions, sine inverse of 8 divided by 11. Round that to the nearest tenth, you guys, and you guys get 46.7 degrees. 46.7 degrees, okay? And again, please make sure that your guys' Desmos is in terms of degrees, right? Not radians. All right, let's take a look at number 11, right? Number 11. Okay, so for number 11, here's our angle perspective, right? 3.7 is the adjacent, 9 is the hypotenuse, right? So we're definitely going to be using cosine, right? Cosine of theta is 3.7 over 9. To solve for theta, right, we need to do cosine inverse to both sides. So boom, boom. So theta, you guys, is going to equals to cosine inverse of 3.7 all over 9. So as you can see, I already put it in your guys' calculator. 3.7 cosine inverse of 3.7 over 9, that is 65.7 degrees, right? 65.7 degrees. Okay, this is kind of lagging. All right, number 12, right? From this angle perspective, 9 is the opposite side, 15 is the hypotenuse. So this is going to be using sine. So sine theta equals opposite over hypotenuse. To solve for theta, you guys need to do sine inverse to both sides, because the sine inverse and sine cancel, so then theta just equals sine inverse of 9 over 15. Put that in the calculator, which I already did for us. Sine inverse of 9 over 15 is 36.9. Round it to the nearest 10, right? Round it to the nearest 10. 36.9. Okay, great. Now, for 13, 14, and 15, you guys, we don't need this for now. We'll come back to that later. 13, 14, and 15, you guys are going to have to utilize your 30, 60, 90, and 45, 45, 90 degree triangle. So, for 13, it's 30, 60, 90, right? Here are the ratios. Across from 30 is x, across from the 60 is x rad 3, and across from the 90 is 2x, right? Now, if you guys look at what we have, well, it seems like we know the side length across from the 60, which means we need to set the 1 equals to 3 rad 3. Now, we have to solve for x, you guys, so we need to divide both sides by rad 3. And lovely, the rad 3's cancel, so x is equals to 3. So that tells us for the 30, that one's 3, and we have 2 times 3 here, which is just 6, right? Now, remember, across from the 30 should be 3. So across from the 30, it should be 3. So C is 3. Across from the 90 is D, so we know across from the 90 is 6. So D is going to equal to 6. Okay. 14. So this one is a 45, 45, 90. And the ratios, you guys, are x, x, and x rad 2. So you are going to have to memorize that, you guys. You are going to have to memorize that. Okay, so the side length we do know is the one across from the 45, which means we need to set this one equals to 10 rad 2. Well, if x is 10 rad 2, you guys, that means this one's also 10 rad 2. And if we plug in 10 rad 2, you guys, into that x, we get 10 rad 2 times rad 2. And remember, A radical times itself is just the number on the inside. So rad 2 times rad 2 is simply just 2. And 10 times 2, you guys, is 20. So we know across from this 45 is 10 rad 2. And we know that across from the 90, we know that it's going to be 20. And last but not least, you guys, number 15, again, it's another 30, 60, 90, x rad 3, 2x. Now, we know the length across from the 90. So that means that this one's going to equals to 4 rad 3. We need to solve for x, so we're going to divide both sides by 2. X equals 2 rad 3. 4 divided by 2 is 2, and then just drop down the rad 3. So now we solve for x. So we know this one is 2 rad 3, and we need to plug in this x in for that one, yeah? So we got 2 rad 3 times rad 3, and you should be getting better at this. Rad 3 times itself is just gonna give you guys 3. 2 times 3 is 6. So across from the 30 is this, so we know D is 2 rad 3, and across from the 60 is C, which is gonna be 6, right? Okay, and last but not least, we have 16 and 17, which is our word problems, right? Our good old word problems, right? Okay, 16. Now, when you guys do this, right, I always tell you guys to draw a right triangle, right? Okay, a ladder is 20 feet long and is leaning against the side of a building. Okay, you guys, a ladder is leaning, so the ladder is the hypotenuse, and it's leaning against the building, so the building is the side length on the side, okay? If the angle formed between the ladder and the ground is 75. Okay, you guys, this is the ground, here is your ladder. This is the angle that is formed from the ground and the ladder. So this is 75. How far is the bottom of the ladder from the base of the building? Well, you guys, here's the bottom of the ladder. Here's the bottom of the building. What is this length? So this is where we need to put our x. So once you set up that, now you guys can solve. So in the perspective of this angle, x is the adjacent, 20 is the hypotenuse, so you guys have to use cosine. Cosine of 75 equals to adjacent over hypotenuse. Put this over 1, and you guys cross multiply. X equals 20 cosine 75, and if you put that in your guys' Desmos, okay, I did it. What is this one? I did it right here. 20 cosine of 75, you guys. That is rounded to the nearest tenth. That's gonna be what's that? 5.2. And don't forget your units. You do need your units. So 5.2 feet. 5.2 feet. Okay. All right. The last one. 17. Okay. So I'm going to build my right triangle. Okay. Good. Right triangle. Okay. From a 200-foot observation tower on the beach. Okay, here's the tower, you guys, and it's 200 feet long. A man at the top of the tower, he spots a lovely whale. Okay. He spots a whale. Yeah. Okay. The angle of depression of the whale is 7 degrees. So you guys, the angle of depression is the angle formed with the ceiling, so that is where you gotta put 7 degrees. But remember, the angle of depression is in the same slot as the angle of elevation, right? So that is that. How far is the whale from the shoreline? How far is the whale from the shoreline, which is the beach? So they are asking you guys for this length. Why won't it let me click my little thing? Okay, it's just lagging. What the heck? Okay, it wants to click everything except for that, which is kind of... Okay, there we go. We want to solve for that. Okay, So what trig function do we have to use? Okay, well, in the perspective of this angle, this is the opposite, this is the adjacent, right? Which is tangent. Tangent of 7 equals to opposite over adjacent. Put the tan 7 over 1, and then you guys gotta cross multiply, right? X tan 7 equals to 200, and then you guys divide both sides by tan 7, right? This cancels. So 200 divided by tan 7, you guys, and if you guys do look at the decimal screen, round it to the nearest tenth, that is 1,628.9 feet. Okay, so hopefully this video helps you guys out. Do practice, do study, and you guys should be good for your guys' exam. Okay, all right, good luck everyone. Peace.